Hi there, I'm Boris, and in this video I will talk to you about JSON Web Tokens. So JSON Web Tokens are a way to securely exchange claims between two parties. That's the standard definition that you may have already heard about JSON Web Tokens, and in this video my goal is to show you what they actually are, so what really is a JWT token, but also what are these tokens used for. And finally, I'd like to show you also what are JWT tokens from a more technical point of view, so about their structure and also discussing their security principles. So first of all, what is a JSON Web Token? So you will hear me telling either JWT or JSON Web Token or JWT or JWT Token. All these names are synonyms in this case, so these are just different pronunciations of the same thing. A JWT is basically a token for exchanging claims. That's the standard definition, and when speaking about JWT tokens, claims are basically information about users or any other subject, for example. So JSON Web Token, well, JSON is for JavaScript Object Notation, as you can see on the right of this slide, and JSON is just a type of notation, a structure for notation, like you can have XML, for example, or other formats like CSV. That's just a way of structuring data that is commonly used in JavaScript. So JSON Web Tokens will use this notation, and JSON Web Tokens is under an open standard, which is the open standard RFC 7519, so we will look at it a bit later in this presentation. And as I said before, these JWT are actually pronounced JWT. Now let's go a bit more in details in their utilization and see what they are used for. This is a basic authentication system, so that's just an example in simplified PHP. The idea is that if you want to build an authentication system, for example, for a website, you will have to receive a couple of information from the user. That's maybe the email and the password of the user that wants to log in to authenticate your website. You will have some function that will process the login, so to match these credentials against your database information, for example, and that finally will return in the user variable, so either a user if someone has been found in your database, or just an authentication error. So when a user is logged in, you will probably store it into some session variable, so that along the whole session of the user on your website, you will remember that the user is connected, and that will just prevent the user from having to log in again and again for every page he visits. This authentication principle is the one illustrated here. That is, a client is, for example, on a mobile phone, wants to log in on some website, so he will provide the email and password. Then the server will store the information of this user in session if the user's credentials are valid, so this email and password credentials. And finally, the server will tell the client that the connection has been successful. And once the user is logged in, well, the server can just check the session variable to know whether the user is still logged in the system or if he needs to log in again. And that's this other principle here, where a client is already logged in, he can try to access some protected resource, so he will tell the server that, well, I'd like to access this protected resource, and I just logged in, so you should remember me. So the server can check the session informations, that's what I just described here in this very simplified PHP code. And if the client is still connected and information are still in the session, then the server can reply to the client with the requested resource. So here is the resource you requested, and well, the information I have about you grants you the access. So that's why the client can access this resource. So this is the very basic principle of how a session works. But there are actually two different types of session that exist, and I want to give you a quick overview of these different types. So these two main types are stateful sessions and stateless sessions. Stateful is when the server knows each client connected thanks to session informations, for instance, as we've just seen with this PHP example. This session principle is used in PHP Session Superglobal, in Node.js with Express Session, and in many other languages and frameworks that you may have already used. This principle is described here, where every client, so for example this client 1, will have the session ID 1, and the server will remember this client thanks to its session ID. So that's why here in the server's memory we have a space for session 1, so which is related to client 1, and another one for client 2, which has session ID 2, and another space in the memory for session number 2. So this is how a server can actually handle multiple connections. Now for stateless session, it's a bit different because the server has actually no idea who is the client making a request. And that's especially used for distant clients and servers, or clients that interact with many microservices that are not on the same server, or other cases where either there is not a single server, or for any other reason the server cannot keep information about each session from the clients. So this principle of stateless session is actually why JWT tokens are very interesting. Back to our JWT tokens then, because we talked a lot about the sessions principles, but that's very important to understand why these JWT tokens are so interesting. Well, JWT tokens login and usage principles are actually using a standard login, as you may do with an email and password from a user. But then the server, instead of storing information in its session, will generate a JWT token that it will send back to the client, and the client will store this token to then send it back to the server on every request. And this token is what will hold the information, the claims about the client session. So in this illustration, they are quite similar to the one we've seen previously with this stateful example, but this time it's with a stateless session using JWT tokens. So the client will still log in with his email and password to the server. The server will this time generate a JWT tokens only if the credentials from the client are valid, of course, and then the server can send back the JWT token to the client. Then the client will store this token to then send back this JWT token when the client wants to access some protected resource. For example, here again the client wants to access some protected resource, so he will tell the server, well, I'd like to access this protected resource, my JWT token is in the request, so the server will verify the information of this JWT token, and if everything's valid and the token is verified, then it can let the client accessing this resource. So at the response from the server to the client, he can say, well, here is the resource you requested, and your JWT tokens grants you the access, so that's why you can access this resource. That's really the key principle of a JWT token. It's to store this session information of a client directly within a token that's given by the client to the server on each request. And when the client logs in, well, the server can just generate this token, give it to the client, and the client will use it on every request. And technically speaking, well, the client can just give this token to the server using the HTTP authorization header. So that's the one described here, where you will have authorization bearer, and this token here is the JWT token. So now I'd like to talk a bit more about these JWT tokens from a technical point of view. So I suggest that we go off this presentation slides, and I will go to the JWT.io website. That's a website created by Auth0, so the authentication company. And this website is actually very interesting because it provides a debugger that you can see here in the menu. And this debugger actually shows you very well how is structured the JWT token and how it works. A JWT token is split into three parts. This that you see here, this information, is a token. This is a JWT token. And it's split in three parts by dots. So the first one in red is the header of the token. So this is the header part here in red. And the header basically contains information about a hashing algorithm that we'll discuss a bit later, and also the type of the token, which is always JWT for JWT token. Then the second part is the payload of the token, and this payload is what contains the data of the token. So this is the part of the token where all claims are stored. For example, here we can see that we have three different claims. We have sub, which is the subject of the token, then name, which is the name of the user, so here John Doe, and IAT, which is issued at, that is the timestamp at which the token has been issued. There are actually two different types of claims. There are registered claims, which are claims specified by the open standard, so the RFC, and public claims, which are basically other information that you can store on the fly. So that means any information that you want. Now I will go to another tab, which is the specification for this JWT token. So I will put you these different links in the description below, but actually this document is very interesting because it's really the core specification of JWT tokens. So if you want really to have the most relevant and the most accurate information about JWT tokens, you can refer directly to this specification. And here what I wanted to show you is that if you go to the table of contents, you will see here that we have registered claim names and also public claim names. If we go into the registered claim names here, you will see that there are different types of registered claim that exist. So I will not go through each of them individually because that will take some time, but I can show you some of the most used in my own experience of JWT tokens. So the first one is for issuer, and that will give you information about who, so which server, which website, which application issued this token. Another one is the subject, and the subject is meant to identify someone uniquely within your system. So if you have, for example, a database with all users of your application that are stored, and each user has a unique ID, then a subject, an example of subject could be this ID, because it identifies uniquely someone in your system. Now, there are also others. As I said, I will not go through each of them, but other ones that are interesting are EXP for expiration time, which will define a timestamp at which the token will expire, and that's very important because you will need to set at some point a way to restrict the lifetime of a token. So other parameters can be IAT for issued at, which is the timestamp at which this token has been issued. And finally, we have also other information like GTI, which is a claim that provides a unique identifier to the JWT token. But something interesting to note here is that all of these registered claims are not mandatory. All of these are optional. That means you can implement your JWT token with only the different claims that you need. Also, regarding the public names, where public names can just basically contain any information that you want. Now, back to this example, we can see that we have the subject, so this may be the ID of John Doe in the system. The name is not a registered claim, so it's a public one. And finally, AAT is this time at which this token has been issued. So this is really for the data of the token. And if we want to add other data, for example, an email address like email john@doe.com, you can easily do that in that way just by adding information. And this way I just added other information about the user directly into this token. And finally, the last part of the token is a signature that will ensure its integrity. The signature is actually generated using a hash that will use this algorithm we specified here in the header. And this algorithm, this hashing algorithm, will generate a hash of the header, so the header itself, of the payload, and finally of a secret key that we will need to provide. And this secret key is the one we can see here. So the key idea for this verification process is that when a server will receive a JWT token, it will create the signature on its own by using the information of the token and its secret key. So it will basically hash the header, payload, and secret key to generate the signature. And if this signature that's been generated by the server does not match the signature provided by the client, so by the JWT token from the client's request, that will mean that the JWT token is not valid. So that gives the overall structure and information that are carried by a JWT token. Now let's discuss a bit more the security part, because you may have many questions about how it works and how this kind of token can be secured and not changed by someone using it, or how they can work on the server if the server is not actually storing any information about the user. Well, I will give you some information about that. The first thing which is interesting is that these different claims that we discussed a bit earlier are actually a key concept for the security of these tokens. Each of these claims, and especially the expire time here, will provide you a way to secure these tokens. So this expiration time claim will give you some additional security by knowing when to accept or not the token when it expires. And others, such as the issuers, so who issued the token, you may trust someone who issued the token or not. The subject will be the user, the ID of the user, for example, using this token, and so on. So all these registered claims will give you additional security to the token. Another important thing to consider when building an application based on JWT tokens for authentication and also session is that the expiration time is really one of the most important parameters, and JWT tokens are generally meant to live between a few minutes and a few hours maximum. So usually in my personal experience, I've usually seen an average time of 15 or 20 minutes of lifespan for a JWT token. This is to keep the control and to be able to easily revoke a token, because if someone has a token with no expiration time, that means this person can use it infinitely. So that's really important to set an expiration time of a few minutes or a few hours maximum for these JWT tokens. As I said before, the signature is also a very important part of the token as it ensures its integrity. So assuming I'm an attackant and I want to steal information from a website or an application, I could have received from the website itself a token that says administrator equals false or admin : false. With this token I have here, I'm a standard user and I don't have any admin access. Now, as an attackant, I could easily try to modify this token to generate another one that I will send back to the server to make it believe that I'm actually an admin. To do so, I will edit this admin false with admin true, and you can see here that the signature just changed. Now, the problem is that this signature actually is generated using only this first information. In other terms, the server will do exactly the same on its side, and the server will take this payload that is given by the client, it will take the payload that is given also by the client, and from that it will generate the signature. Problem is that if there is no secret key, well, the server will generate the signature with information given by the client, and that's very dangerous because any information given by a client will be trusted. So to prevent this, the idea is to add a secret key here that is only known by the server. For example, let's add a key that looks like server-key. So that should be something more secure, but that's just for the example. And now if I'm a user again and I receive this admin false token by the server, this is the token I will receive. So I will copy this token and put it in some text editor. And as an attackant, I will try to change again this value. The problem is that now I don't know what's the secret key that the server used. So if I change this admin false with admin true, but I keep the same signature, I will just copy here the signature, I will change admin false to admin true. So here the token is still valid because JWT debugger is automatically regenerating the signature. But as an attackant, I will not have the secret key here, the server secret key, to generate the right signature. So if my signature remains the same, like this one, well, this signature becomes invalid. And that's the problem. The server itself will know that the token is not valid because the signature is not. And the reason why the signature cannot be valid is because the client doesn't know the secret key that's here. This secret key is only kept by the server itself. So as long as the client doesn't know the secret key, he will not be able to generate the right signature, and the server will know that the token is not valid. Again, the idea is that when the server will receive this token, it will basically do the same as the client but with the secret key. It will take the header, the payload, and the secret key, generate the hash of all of this, and if the signature generated by the server is the same that the one provided by the client, then that means the token is valid. And in this case, if you try to provide some information to the server with a modified token, it will notice that something is wrong with it. Now you may ask, well, what if the secret key is leaked? Well, that's one of the biggest problems that you may encounter, because if the secret key is leaked, anyone who has the secret key can actually generate a token that will be recognized as valid by your server, and that's really problematic. For example, here let's assume that as a client we know the secret key, and this using the key now, well, the server will think that the token is actually valid because we have the secret key that allows us to generate the right signature. That's why the secret key really needs to remain secret. So if for any reason the secret key leaked, well, the best option you have is just to change it on the server so that any token will be considered as invalid, so your different clients or users will have to connect again, but that will prevent your server to trust any token that's being sent. So this is for the security principles, and now one last thing that's important to understand with these tokens is that they are not hashed nor encrypted, but they are only signed. So a hash is actually used, in this case HS256, but you have other algorithms, but this hash is only used to generate the signature. And the token itself is not encrypted or not hashed or anything, it's just encoded in base 64. That means if you have as a user a token like this one, I can basically take the contents, so here the payloads, I will copy this payload and paste it here in base 64 decode, so a base 64 decoder. If I paste this payload and I click on decode, you can see here that we have all information of the token that are given. So we have here our subject, the name of the subject, his email address, his administrator status, etc. All of this information are given here in clear. So you may think that's not very secured, but in reality the reason for that is because the encryption of the token is generally delegated to the communication channel. In other terms, when you transmit a JWT token, you exchange it with someone or some server, that will go through HTTP, and more precisely HTTPS, which is the secured protocol, and because the HTTPS is itself encrypted, well, that will allow the token to be implicitly encrypted. So that's the reason why these tokens are only signed and not encrypted. But to be totally precise about that, well, these tokens can also be encrypted. That's another option, and if you read this specification, you will see that the claims can either be signed, so with a signature at the end, or they can also be encrypted directly to encrypt especially the payload information. This leads us to the conclusion of this video, and to conclude, well, I'd say that JWT tokens are quite simple and their approach and mechanism is very efficient and actually quite intuitive once you know it and you get used to it. It's also very flexible for stateless sessions, and it reduces the server-side overhead, because with JWT tokens there is no need to store session data for each user on the server side. But on the other hand, well, that increases the overhead in each client's request, because this token has to be transmitted from the client to the server on every request, so that can really increase the size of the request. And that's also why it's important to keep in mind that it's better to have not too much information in the JWT tokens, but only really relevant information about the user that will allow you to authorize or not the access to some resource of your application to this client. And well, it also needs to be properly implemented to prevent any security issues on your application, and the different JWT claims, well, the registered one like expires, issuer, etc., have to be included. Even if they are optional, that's better to include at least some of them to increase the security of your system. And finally, well, you heard me talking about short lifespan tokens that can last around 15 to 20 minutes, for instance, and that will mean that every 15 to 20 minutes the user will have to log in again so that the server generates a new JWT token that it sends back to the client, and then the client can give you this token back in every request. So in order for the clients not to have to log in every 15 or 20 minutes, well, there are other mechanisms that consist in using two different tokens, so one JWT token and another one that's called a refresh token, which can also be a JWT token, to allow the user to refresh, so that is actually to generate automatically another JWT token when the first one is close to expire. But these are some mechanisms that I will not cover in this video, and I will put you some links in the description below if you want to know more about it. So thank you very much for watching this video. I hope you enjoyed it and that you have been able to learn some things about these JWT tokens. If you have any questions, please feel free to ask them in the comment sections below. And also, if you want to learn some things about these JWT tokens, their implementation in PHP, in Node.js, or in any programming language, well, you can also ask me in comments. I really hope you enjoyed this video. That's also for me an exercise actually to train my English speaking, because as you've noticed, English is not my native language. So I really hope that you enjoyed it, that you have been able to learn something from it, and if this is the case, well, please subscribe to this YouTube channel and hit the like button, and I will see you in the next video.